So yesterday we looked at Pythagorean theorem and saw that we can find a missing side in a right triangle. As long as we have two sides, we can find the third side by using a squared plus b squared equals c squared, where a and b are the two legs of the triangle, c is the hypotenuse. So now we're going to get into using what are known as the trig ratios. And we're going to see that we can use these to find missing angles in right triangles, as well as finding a missing side if we only have one side. Because if we have two sides, we can use Pythagorean theorem to find the third. That's what we did yesterday. But we're going to see how we can use these trig ratios to find a missing angle in a right triangle or a missing side as long as we have one other side. And the three trig ratios are the sine of the angle, the cosine of the angle, and the tangent of the angle. Those are our three trig ratios. But before we look at these trig ratios, we have to learn how we're going to label the sides of a triangle. So this says label the triangle below with respect to the reference angle theta using these words, opposite, adjacent, and hypotenuse. And then we will complete the trig ratios. So we saw yesterday that the hypotenuse is always the side across from the right angle. The hypotenuse is always the side across from the right angle. And as we go through this chapter, we're going to be doing this lots, where our first step is always label the sides of the right triangle. And the side across from the right angle is always the hypotenuse. Okay, Ethan, you need to put your phone away and copy this down. Now, here's the next step, and this is important. You're always going to be either given an angle that you're going to use, or you're trying to find an angle. Whatever that angle is, which in this case is labeled theta, and theta is just a Greek letter that's used to represent an unknown angle often. So you're either going to be given an angle that you're going to use, or you're trying to find a specific angle. That angle will always be theta, and the side across from that angle, the angle that you're given and you're going to use or you're trying to find, is the opposite side. It's going to be opposite the angle that you're working with. Either you're given it and you're going to use it, or you're trying to find it. So we're always going to label our triangles this way, where we'll start with the hypotenuse first, the side across from the right angle. Then we'll look and see, are we given an angle that we're going to use, or are we trying to find an angle? Whatever the side across from that angle is, that's labeled the opposite. And that only leaves us with one side left, which would be the adjacent side. So the adjacent side will always be the one that's left. Adjacent actually means beside or close to. You see, this side is beside the angle theta. It's close to the angle theta. Now you might argue, well, the hypotenuse is as well, and that's true, but we've already labeled that side. The side across from the right angle has to be the hypotenuse. So this is how we're going to label our three sides of our right triangles. And again, you have to have a right triangle, which means a 90-degree triangle for this to work. To be able to use these trig ratios, you must have a right angle triangle, because only a right angle triangle has a hypotenuse. A hypotenuse is the side across from the right angle. And then, once you have that, we have our three primary trig ratios. And there's a word that has been used for many years to help us remember what those ratios are. And that word is SOHCAHTOA. Now, you will be given this word on a formula sheet whenever we have a quiz or a test for this chapter. You'll also be given the three ratios. Okay, but if you don't have a formula sheet handy, let's say you're doing an assignment at home and you don't have your formula sheet handy, then you can use this word. So the S stands for sine, and the other letters correspond to the three sides that we have on our triangle. The three sides are the opposite, adjacent, and the hypotenuse. So this so means sine uses the opposite and the hypotenuse. O stands for opposite, H stands for hypotenuse. And the order that they are is also important. Opposite is first, hypotenuse is second. These are trig ratios, and ratios are fractions, one over another. This means that sine is opposite first, hypotenuse second. Opposite on top, hypotenuse on the bottom. This is the definition of the sine ratio. The sine of an angle will be a decimal, and that decimal will be equal to the ratio, the length of the side that's opposite the angle divided by the length of the hypotenuse. That's what the sine of theta tells us. So, if you have your calculator, now in order for this to work, your calculator must be in what's known as the degree mode. So on my calculator, I have to press the mode button, and the third line down, I have either radians or degrees. My calculator must be in degree mode for this to work. Other calculators will have a DRG button that you have to press to make sure you are in degrees. So you should see DEG probably noted in your window on your calculator when it's on. And then once we do that, we can go ahead and do this. So just to make sure your calculator is in the right mode. Most calculators, you're going to press the sine button first, or the cosine, or the tangent. You see, on my calculator, I've got SIN for sine, COS for cosine, TAN for tangent. So all scientific calculators will have a sine, cosine, tan button. If you're in the right mode and you press the sine of 30 degrees and hit enter, it gives you 0.5. Some calculators you have to put the 30 degrees first and then press the sine button to get the 0.5. You should all be doing this right now to make sure that your calculator is in the right mode and it's working. When you take the sine of 30, you should get 0.5. Anyone's not working? You have to be able to know how to do this because you're going to be using these buttons in order to answer questions, to find missing sides and missing angles in right triangles. When you take the sine of 30 degrees, you have to get 0.5. That tells me that your calculator is in the right mode and that it's working properly. So, what does that mean? Well, we've seen that the sine is the ratio of the length of the side opposite theta divided by the hypotenuse. So what this means is if you have a triangle, a right triangle with a 30-degree angle in it, the ratio of the side opposite 30 degrees divided by the length of the hypotenuse will be 0.5 or a half. It means that the opposite side is half the hypotenuse, because when you divide them, you get 0.5. And the only way that'll work is if the length of the side opposite the angle theta is half the length of the hypotenuse. If the opposite side was 5, the hypotenuse would have to be 10, because the ratio of sine is 0.5 if you have an angle of 30 degrees that you're working from. If the opposite side is 7, the hypotenuse would have to be 14, so that you get a ratio of 0.5. Your calculator has programmed in it the sine, the cos, and the tangent of every angle between not only 0 and 90 degrees, but actually from negative infinity to positive infinity. We are only going to be using angles between 0 and 90 degrees, but all angles are programmed in there. Your calculator will give you the sine, cosine, tan of every angle that you can think of. But we'll only be working with angles between 0 and 90 degrees. So that's the sine ratio. The ka part of SOHCAHTOA tells us what the cosine ratio is. So again, these letters, the C stands for cosine, The A stands for adjacent side, and again the H stands for the hypotenuse, and the order matters. A is first, H is second. Adjacent is first, hypotenuse is second. And these are a ratio. A ratio is one number divided by another. So adjacent is on top, hypotenuse is on the bottom. That is the cosine ratio. So no matter what angle you have, you can find the cosine of that angle by using your calculator. And so if we did, let's say, cosine of, so cos is a COS button, of 80 degrees. It's that decimal, 0.173648177. Most of these are going to be irrational numbers, non-repeating, non-terminating decimals. It just so happens when we check the last one for 30 degrees, the sign of it was exactly 0.5. Usually that doesn't happen. Usually it's going to be an irrational number, a non-repeating, non-terminating decimal. I guess it's not irrational because it actually is a ratio. It's the side adjacent divided by the side hypotenuse. So it can be written as a fraction, but your calculator gives it to you as a decimal. So if you had a right triangle where one of the angles, besides the 90 degrees, one of the other angles was 80 degrees, this means that if you took the length of the adjacent side and divided by the length of the hypotenuse, it would equal this decimal, because that's what the definition of cosine is. And my calculator won't even give it to us as a fraction. It just gives it to us as a decimal. Okay, so the last one is the tangent. That's what the T stands for. And again, the letters O and A stand for the opposite and the adjacent. Opposite first, adjacent second. That means opposite on top and adjacent on the bottom. That is the tan ratio. And so, again, if we take the tangent of any angle between 0 and 90, let's say the tangent of 25 degrees, it's that decimal, 0.46630, and there's more numbers there. But what that means is if you had a right triangle, which means it has a 90-degree angle in it, but also one of the other angles is 25 degrees, from that angle, if you took the length of the opposite and divided by the length of the adjacent, this is a decimal it would give you. 0.4663076582, and there's more numbers there. Right? But we don't have to find the length of the opposite and the adjacent and divide them, because our calculator tells us that from an angle of 25 degrees, if you divide the opposite by the adjacent, that's the tan ratio, TOA tells us that, you'll get the tan of 25, which is 0.4663, and there's more decimals there. So these are the three trig ratios. And if we go back to that second page, the page on the back side of the cover, not only is Pythagorean theorem written there, but also the triangle, the way it's labeled, the sides, from theta, the opposite, adjacent, and hypotenuse, as well. There's SOHCAHTOA and the three ratios written out. So you don't have to memorize them. You'll be given this sheet for any quizzes or tests. But like I said, if you're at home doing a homework assignment and you don't have this part with you, if you can remember SOHCAHTOA, that'll tell you what the ratios are. So let's just do a bit more practice with using these ratios. So you've got a triangle there, a 3, 4, 5 triangle. And you're asked to write each trig ratio. So when we write these trig ratios, it's never from the 90-degree angle. It's always from one of the other two angles that are less than 90, which in this case would be angle A and angle B. So that's why we have the sine, cos, and tan of angle A, and we also have the sine, cos, and tan of angle B. We'll do each one separate, starting with angle A. So let's say we're working from angle A. So that is theta, the angle we're working from. This is important because we need to know what angle we're working from so we can properly label the sides of the triangle. It doesn't change the hypotenuse. The hypotenuse is always the side across from the right angle. That never changes. But the opposite and the adjacent side will change depending on which angle you're working from. So if we're working from angle A and that's theta, the side across from that is the opposite, and that leaves us with the last side to be the adjacent. If you're working from angle A, this is how the triangle must be labeled. The hypotenuse never changes, but the opposite and the adjacent side will. Another reason why we never work from the 90-degree angle, angle C, if you said you were working from the 90-degree angle, angle C, that would make the 5 both the opposite and the hypotenuse, because the hypotenuse is the side across from the right angle. And if you say you're going to work from the 90-degree angle, angle C, then you'd also want to label that side the opposite as well, because it's across from the angle you want to work from. Can't have one side with two labels to it. Another reason why, if you try and take the tangent of 90 degrees, let's say you're working from that angle, you get an error. The tangent of 90 degrees does not exist. So that's a couple reasons why when we're setting up our triangle and using angle theta to label the three sides, it can never be the 90-degree angle. It has to be one of the two other angles. Okay, so from angle A, we've labeled our sides, so now we can write our ratio. Sine is opposite over hypotenuse. That's what SOHCAHTOA tells us. That's what we have written above. Sine is opposite over hypotenuse. So from angle A, the opposite side is 4, the hypotenuse is 5. That's the definition of the sine of angle A, the value of the sine of angle A. Next, we'll do the cosine of angle A. We'll do all three angle A's first, and then we got to go back and adjust our diagram if we're working from angle B instead of A. But we've got angle A set up here, so let's do all three ratios for angle A. The cosine, if we look above, the cosine is the adjacent over the hypotenuse. And from angle A, the adjacent is 3 divided by the hypotenuse, which is 5. And then the tangent of angle A, if we look above, tangent is opposite over adjacent. So from angle A, the opposite is 4, the adjacent is 3. So there's our three ratios from angle A. Now, what if we want to now do it from angle B? So now we're going to work from angle B. B will be theta. It doesn't change the hypotenuse. The hypotenuse is always the side across from the right angle. But now the side across from angle theta, that's 3, that is the opposite. And the other side that's left now becomes the adjacent. So now we can write our three ratios for angle B, starting with the sine. Sine is opposite over hypotenuse. That'll be 3 over 5. Notice the sine of A was 4 over 5. It's different. The cosine of B, cosine is adjacent over hypotenuse, would be 4 over 5. Again, that's different than the cosine of A. Cosine of A was 3/5. The cosine of B is 4/5. And the tangent of B, opposite over adjacent, is 3 over 4. It's the reciprocal of the tangent of A. That was 4/3. For B, it's 3/4. So there are your sine, cosine, tangent for angles A and B. Again, we'll never work from the right angle, which in this case is C. It's always working from one of the other two angles that are less than 90. All right, so we'll do the same thing for this next example. But we can't work from angle L, that's our right angle. So let's say we're going to work from angle M first. Let's say that is theta. Well, the hypotenuse never changes. That's always the side across from the right angle. We've chosen to start with angle M first. The side across from that is the opposite. And then you're left with the third side to be the adjacent. So working from angle M, this is how we would label the sides of the triangle. And now we can state the sine, cosine, tan. You can do them in any order you want. I just always do sine, then cosine, tan. So from angle M, the sine of M, and by definition, at the top of the page, sine is opposite over hypotenuse, 5 over 13. 12 over 13. Opposite is 12. Next, we'll do the cosine of angle M. Cosine is adjacent over hypotenuse. That's 5 over 13. And then finally, the tangent of angle M, opposite over adjacent, 12 over 5. And now when we switch to angle N, that's our other angle that's not 90 degrees. That's going to change our adjacent and our opposite. The hypotenuse never changes. That's always the side across from the right angle. But now when we switch to angle N, now the 5 becomes the opposite because it's opposite to or across from the angle we're working from. And that leaves us 12 to be the adjacent. So the sine of N, sine is opposite over hypotenuse, 5 over 13. The cosine of N, cosine is adjacent over hypotenuse, that'll be 12 over 13. And the tangent of N, tangent is opposite over adjacent, that'll be 5 over 12. You may have noticed that the sine of N and the cosine of M are the same ratio, 5 over 13. Also, the sine of M and the cosine of N are also the same ratio, 12 over 13. Also, the tangents of the two angles are reciprocals of each other. That will always happen. Okay? The sine of one will be the same as the cosine of the other. The cosine of one will be the same as the sine of the other. And the tangent ratios are always reciprocals of each other. That will always happen. Try this one on your own. Again, you're working from angles A and B only because C is the right angle. So if we decide to start with angle A first, we could start with B first. That doesn't matter. It won't change the answers in any way. But we have to first label the sides of the triangle. Side across from the right angle is always the hypotenuse. That never changes. We decided to start with angle A first. That's where theta is, so the side across from that is the opposite. Third side is the adjacent side. So based on that, the sine of angle A, and the definition of sine is opposite over hypotenuse, would be 6.3 over 10.2. Opposite over hypotenuse. The cosine of angle A, definition of cosine is adjacent over hypotenuse. That'll be 8.2 over 10.2. And the tangent of angle A, definition of tangent is opposite over adjacent. 6.3 over 8.2. Right, so there's our three ratios for angle A. Now if we're going to switch gears and do angle B instead. Now B will be theta. That doesn't change the hypotenuse. It's always the side across from the right angle. But now the side across from the angle that we're working from, 8.2, now that becomes the opposite, and we're left with 6.3 to be the adjacent. So the sine of B, sine is opposite over hypotenuse. That'll be 8.2 over 10.2. The cosine of B, that's adjacent over hypotenuse, 6.3 over 10.2. And the tangent of B, tangent is opposite over adjacent, 8.2 over 6.3. So there are the ratios for the two angles that are smaller than 90 degrees. We never work from the 90-degree angle. Are we good with this? Do we need to do the next one as well, or are we good? Thumbs up? Okay. So before we start using these to solve problems, we need to be able to once again use our calculator with sine, cos, or tangent. Since all the angles we encounter will be expressed in degrees, we must be in degree mode. We've already talked about that. So just to make sure, let's use our calculators to find the value of each of these to 4 decimal places. The first one is the tangent of 25. So we'll go tan of 25. Tan 25. To 4 decimal places, it'll be 0.4663. If you're getting that on your calculator, then you're doing it right. It means your calculator's in the right mode, and you're doing it right. For most of the calculators, you're going to hit the tan key first and then type in 25 and enter. There might be some, though, that you have to do the 25 first and then hit the tan key. One of those two ways. So you need to make sure that yours is working, that you know which steps you have to do. The next one is the sine of 42 degrees. So it's sine of 42, enter. That's 0.6691. Now I'm rounding to 4 decimal places. So in each case, I'm looking at the decimal in the 4th spot, as well as the number to the right of that. And in both cases, the number to the right was less than 5, which meant that the number in the 4th position stayed the same, 0.6691. And the last one is the cosine of 68 degrees. 0.3746, and the digit to the right of the 6 is a 0, which means the 6 stays the same. It doesn't go up. 0.3746. Right, so there's the value of for each of those. Now, what we did in example 2 is we were given the angle. So we just typed it in our calculator. The tan of 25 equals this decimal, 0.4663. Sometimes you're going to be given the decimal and you want to find the angle instead. So it's the opposite of what we just did. Above, you were given the angle, we found the decimal. In example 3, we're given the decimal, we want to find the angle. So it's the opposite. And this is where our second function stuff comes in. You see, above the tan key, it says tan to the negative 1. Above the cos key, it says cos to the negative 1. Above the sine key, it says sine to the negative 1. This is where we use those. When you're given the decimal and you want to find the angle, so for question A, if the tan of theta is 1.2115, and we want to find the measure of the angle to the nearest degree, in our calculator, we're going to go tan to the negative 1 of 1.2115. And when we hit enter, it'll tell us what the angle is. We just have to round it to the nearest degree. So in my calculator, to get that tan to the negative 1, I have to hit second function first, and then hit the tan key. And then you can see it says tan to the negative 1. I have to type that decimal in there, the whole decimal, 1.2115, hit enter, and that's our angle. That's the angle that when we take the tangent of it, we get 1.2115. Now we're going to round it to the nearest degree like it says, which means the digit in the 1 spot is a 0. To the right of that is a 4, which means the 0 stays the same. Theta is approximately 50 degrees. And we say approximately because we rounded. We rounded the angle. Now, you can check. If I use that entire decimal and I go the tangent of that decimal, the tangent of the previous answer, it'll give me exactly the 1.2115 that we were given to start with. If you don't use the exact decimal, but you just use the rounded value that we got of 50 degrees, it's going to be close to 1.2115, but it's not the same because we used a rounded value. Right? So you can check your answers, but it's always best to use the entire decimal. And if you don't know how to use your memory on your calculator, you can just retype in all the numbers that you see. Okay? When we did the second function 10, we got 50.4629, and there's more. 50.4629, and then there's 4983. If you hit enter, you're going to get close. Actually, you are going to get 1.2115. So if you type in the entire angle, decimal and all, you should get the value that you were given at the start as a check. So for question B, you're told the sine of theta is that decimal. To find out what theta is, you have to go second function sine. You got to go sine to the negative 1 of that decimal. And when you do that, it'll tell you the angle theta such that the sine of that angle equals 0.4771. So second function sine of 0.4771. So to the nearest degree, that would be 28 degrees. And again, if you just check 28 degrees, you won't get 0.4771. To check it, you'd have to go the sine of that entire decimal, 28.496169, 16911. And you get the right decimal, 0.4771. That tells us that our angle is correct. It's the angle such that the sine of that angle equals 0.4771. And for the last one, if the cosine is that decimal, to find out what the angle is, we have to go close to the negative 1 of that decimal. The cosine of an angle theta is 0.7225. To find out what the angle is, such that the cosine of that angle does equal 0.7225, we have to go second function cos. Second function cos of 0.7225. So if I round this to the nearest degree, it would be 44 degrees. 43.7 means that the 3 rounds up to a 4. So theta is approximately 44 degrees. And if I wanted to check that again, I'd have to do the cosine of the entire angle that's in my calculator, 43.73872733. And you get the right decimal, 0.7225. So you can always check these. You should never get them wrong. So this is one of the steps we're going to do when we're finding a missing angle in a right triangle. We're going to do something very similar to what we just did to find a missing angle in a triangle. So this says complete the table below, record the ratios to 4 decimal places and the angles to the nearest degree. So for the first one, we're given the angle to be 27 degrees. I want to find the sine, cosine, tangent of that angle. So I just put it in my calculator. Sine of 27 degrees to 4 decimals is 0.45. Now, I have a 3, then I have a 9. The first 9 is in the 4th position. And because the next digit is also a 9, that means the first 9 has to go up, or 39 has to become 40. So it's 0.4540. The next one is the cosine of the angle. The cosine of 27 degrees to 4 decimal places is 0.8910. So the first 0 is in the 4th position. The digit to the right of that is also a 0, which means the first one doesn't change. It's 0.8910. And then finally, we want the tangent of 27 degrees, 0.5095 to 4 decimal places. So just using the calculator. Now, for the next one, if we look in the next row, the only number we see there is that 0.5543. And if we look above, that's the tangent column. This is telling us that the tangent of an angle theta is 0.5543. Ethan, put your phone away. This is telling us that the tangent of the angle is 0.5543. If we want to find out what angle theta is, we'll have to go second function tan. We're going to have to go tan to the negative 1 of 0.5543 to find out what the angle is. So second function tan of 0.5543. It says to round to the nearest degree, which in this case would be 29 degrees. I mean, that decimal, 28.9996, that's really close to 29. But that is our angle theta, so that goes in the theta column. That's our angle. And now that we know the angle is 29, we can just do the sine of 29, which is 0.4848 to 4 decimal places, as well as the cosine of 29, 0.8746. Now for that next row, the only number we see is the 0.4384. And if we look up, that's the sine column. This is telling us that the sine of theta is 0.4384. To find out what theta is, we're going to have to go sine to the negative 1 of 0.4384. This will tell us what the angle theta is. The sine of theta is 0.4384, so to find theta, we have to work backwards. We have to go second function sine of, try that again, second function sine of 0.4384, 26 degrees. Very close to 26. That's 26.0018. So there's our angle theta. So what I'm missing, the next two spaces in this row are the cosine and the tangent of theta, which is 26 degrees. So we'll do the cosine of 26. That's 0.89. Now, 0.898, and then 7 is in the fourth position. To the right of that is a 9, which means the 7 has to go up by 1. So it'll be 0.8988. And the next one is the tangent of that angle, the tangent of 26 degrees. The 4 decimals, 0.4877. So for this last row, the only number we have is a 0.2079, and that is in the cosine column. The cosine of our angle is 0.2079. So to find out what the angle is, we have to go close to the -1 of 0.2079. So second function cos of 0.2079. (78.0006.848) 78 degrees. And now the next space is for the sine of that angle, so we'll take the sine of 78.9781. The 1 is in the fourth position. To the right of that is a 4, which means the 1 stays the same. 0.9781. And then we're missing a space for the tangent of that angle, the tangent of 78. 4.7046. The 4 decimals. So you may have noticed that all the decimals in the sine and cosine column are all less than 1. That always happens. However, the tangent can be greater than 1, like the last one. Okay? The tangent can be greater than 1. But the sine and cosine of every angle will always be a decimal between 0 and 1. As long as the angle is between 0 and 90, that's going to happen. Because you can find the sine and cos and tan of angles greater than 90. We're not going to do that in this class. But in some of the other classes, we do talk about angles greater than 90. We also talk about negative angles. But that's not part of this class. Okay, we're almost done this for today. Example 4 says, which trig ratio could be used to find the unknown in each of the following triangles? Again, we're working towards a process where we can find missing sides and missing angles in right triangles. And this is what we're going to be doing. We're going to determine what ratio can be used, and then we're actually going to go ahead and use that ratio as our next step. But for this one, it just says what ratio. And this is, again, where you have to make sure you label the sides of the triangle properly. So for this first triangle, the side across from the right angle is always the hypotenuse. That never changes. Notice that you're given that angle in the bottom left hand to be 60 degrees. That's theta. That's the angle you're going to use. So the side across from that is the opposite. The third side is the adjacent side. So for this triangle, if you're using that 60-degree angle, this is how it must be labeled. This way, because you're using the 60-degree angle. And in this case, you want to find the opposite, which is x, and you're given the adjacent side, which is 10. You're not given the hypotenuse, you're not asked to find it, not using it. You want to find the x, which is the opposite side. You're given the 10, which is the adjacent side. So I'm going to just kind of group these together as a reminder that these are the two sides that I'm going to use. I'm going to use the opposite and the adjacent. And if you remember SOHCAHTOA, only one ratio uses the opposite and the adjacent. Only one ratio uses O and A, which is the tangent. Sine uses opposite but not adjacent. It only uses O and H. Cosine uses adjacent but not opposite. It uses adjacent and hypotenuse. Only the tangent, uses O and A, opposite and adjacent, which are the two sides that we have grouped together. Because we want to find x, which is the opposite, and we're given 10, which is the adjacent. Excuse me. So, the next one. Let's start by labeling the sides. Here's our right angle in the bottom right. The side across from that is the hypotenuse. That never changes. In this case, we're given that 24-degree angle. That's the angle we're going to use. That is theta. The side across from that is the opposite. The third side is the adjacent side. So if you're working from the 24-degree angle, because that's the angle we're given, this is how the sides must be labeled. Again, we never work from the 90-degree angle. So in this case, we're given the 4, which is the opposite. We want to find x, which is the hypotenuse. In this case, we're using the hypotenuse and the opposite. Only one ratio uses those two sides only, and that is the sine ratio. The so part tells us that sine is opposite and hypotenuse, opposite over hypotenuse. Cosine uses hypotenuse but not opposite. Tangent uses opposite but not hypotenuse. Only the sine uses those two sides. So this would be the sine ratio. Try the next one on your own, and then we'll check it. Which ratio will be used for the next one? Either the sine, cosine, or tangent. Which one? Side across from the right angle is the hypotenuse. That never changes. In this case, we're given that 32-degree angle. That's theta. The side across from that is the opposite. The third side is the adjacent side. In this case here, we're given the 13, which is the hypotenuse. We want to find x, which is the adjacent. We are using the adjacent and the hypotenuse. We're not given the opposite, not asked to find it, not using it. And the ratio that uses adjacent and hypotenuse is the cosine ratio. That's what the ka part of SOHCAHTOA tells us. Cosine is adjacent over hypotenuse. Do the last one on your own, and then we'll check it. So the right angle's up here in the top left corner. The side across from that is the hypotenuse. You can see that theta is labeled there. So that's the angle in this case that we'd be trying to find. We're trying to find theta. The side across from that is the opposite. Third side is the adjacent. In this case, we're using the opposite and hypotenuse. Those are the two sides that we're given. So we would use those to find theta, along with the appropriate trig ratio, which would be the sine ratio, because only sine uses opposite and hypotenuse. That's what the so part of SOHCAHTOA tells us. This must be the sine ratio. Okay? So we'll stop there. I'll hand out the assignment for you to work on.